Welcome to this presentation on question 4 of paper 1 of STEP 2001. This is quite a long question. I'm going to do two presentations. So in this presentation we're going to do the first part, which is this part here, where we have to show this trigonometric identity, tan 3 theta, and then then essentially apply it to prove this other identity here, this other value. So this is tan 3 theta, and tan 3 theta is equal to sine 3 theta over cos 3 theta. And although there are formula for this, I can't remember them, or I can't remember most of them, so what I'm going to do is I'm going to work out what sine 3 theta is by working from sine 2 theta and sine 1 theta. Let me go about this. What I do know, a formula that I'm going to use, is that sine of a plus b is equal to sine of a cos b plus cos of a sine b. So I'm going to use this formula. I'm also going to use another formula. Cosine of a plus b is equal to cosine of a cosine of b minus sine of a sine of b. Now I want to build up on this side a little bit of machinery, which we're then going to use. The piece of machinery I want to build up is first of all the double angle formula. So let's assume that A is equal to B, or B is equal to A. Then I want to say, well, in that case I've got here sine of 2A, which is equal to, because B is equal to A, sine of A cos of B, it's cos of A because B is equal to A, plus cos of A sine of A, and that's equal to, well, that's sine of A cos of A plus cos of A sine of A, well, that's equal to 2 sine of A cos of A. Now you might have known that already as the double angle formula, but I've just worked it out from there. Now I want to do it again, something similar, but this time B equals 2A. Now if I substitute B equals 2A into this formula here, I will have sine of 3A, and this is what I want over here. I want sine 3A over here, sine 3 theta. So this is equal to sine of A cos of 2A, because cos of B up here is 2A, plus cos of A sine B, which is sine of 2A. So that I'm going to substitute that in, but I need to do the same for cosine here. So let's here say that B is equal to A, and find that cosine of 2A is equal to cosine A cosine B, cosine A cosine B, which is cosine squared A, minus sine A sine B, but B is equal to A, so that's sine A sine A, which is sine squared of A. Let me now do the same again. Here we'll just build up this machinery. B is equal to 2A. Now applying that into this equation here, you get cos of, in this case, 3A, because it's A plus 2B. B is 2A, so that's A plus 2A, it's 3A. And that's equal to cos of A cos of B, which is cos of 2A, minus sine of A sine of A sine of 2A. So, having done all of that, I want to apply that into here. So sine theta over cos theta. Now I've done it in terms of A. Let's try and write it using A instead of theta. See if I can manage that. So I'm going to have a big line here. The numerator is going to be sine of 3 theta, which I've sort of worked out here. I want to substitute this in. So this is sine of A cos of 2A. Cos of 2A here is this equation here. So what I want to do there is put in brackets cos squared A. I've written A. Well, I better keep writing A or I get very confused. Sine squared A. And then going back to this equation plus cos of A. What have I got? I've got sine of 2A. And sine of 2A was 2 sine A cos A, which was what I substituted in from here. Okay, so the bottom line, the denominator, is cos of 3 theta, or cos of 3A. So now I'm going to be working with this equation. Cos of 3A is equal to cos of A, cos of 2A, which is cos squared A, minus sine squared A, minus sine of A, sine of 2A on this equation here. Remember, sine of 2A is 2 sine A cos A. Whew. Okay, well let's simplify this a little bit. It does simplify. Big line for the no. Let's look at the numerator. Starts off sine A cos squared A. If I look over to this term here, this is cos A sine A cos A. So that's also cos squared A sine A, except there's 2 of them. So in total that will be 3 sine A cos squared A. That's dealt with most of it, but I'm left with sine A here times sine squared A here, which is minus sine cubed A. That's the numerator. The denominator, something similar happens. I can start with cos A cos squared A, which is going to be cos cubed A. Then I've got cos A sine squared, minus one of those. And over here, I've also got a cos A sine squared A, but minus 2 of them. So that totals to minus 3 cos A sine squared A. Right. So we're making progress. To make further progress, what I need to do is convert this into tangents. So I want to do this. I'm going to divide top and bottom by cos cubed A. Now I'm going to remember that tan of A is equal to sine A over cos of A. I'm going to use these 2 things. Maybe I'll just change color as we move to this other part. So this is equal to, now I'm dividing by cos cubed A. So the cos cubed A is going to cancel the cos squared A and leave one cos over. And I'm going to get left with 3 sine A over cos A, which is 3 tan A. The next term is sine cubed A over cos cubed A, which is sine A over cos A cubed, which, using this, is tan cubed A. Just dividing every term by cos cubed A. The easiest of all, the denominator, divide cos cubed A by cos cubed A, I'll get 1. Now I've got minus 3 of something, cos cubed A into this. The cos A will go, left with sine squared over cos squared, which is tan squared A. Okay, that kind of worked because this was a homogeneous, it was the same number of sines and coses, and so we ended up with a nice tangent. And in fact, that is what we have to prove. I'll write QED here, quadrat demonstrandum, which is what you used to write at the end of proofs to show that you've now proved what you were asked to prove. I used A instead of theta, but I think we'll be forgiven for that. Okay, so let's just go on to the next part here. I will change color. Let's go to see if we can get a purplish color here. And now we're trying to find, we're given that theta is equal to cos to the minus 1, 2 over root 5. We're also given over here that theta is between 0 and pi over 2. not at 90 degrees. So I can draw a little triangle. We know it's just an ordinary angle less than 90 degrees. So if that was theta, its cosine, theta is the angle whose cosine is 2 adjacent over root 5. And so it looks like that, and by Pythagoras we can work out the length of the other side is 1, because 1 squared plus 2 squared is equal to 5, root 5 squared. And that tells us that tan theta is equal to opposite over adjacent, which is a half. And they asked us for tan 3 theta. Well, tan 3 theta, we've just worked out this formula. It'd be amazing if we didn't have to use it. Let me write it out again. It's 3 tan of theta minus tan cube theta. Use theta this time instead of a. 1 minus 3 tan squared theta. And this is equal to, now I've just got to substitute in 3 times a half minus a half cubed, which is an 8, divided by 1 minus 3 times tan squared theta, which is the square of a half, which is a quarter, which is a quarter. Okay, and here we need just a little more space. This is equal to 1 1/2, which is 12 over 8, minus 1 over 8 over 1 minus 3/4, which is a quarter. And this is equal to, I think we should multiply top and bottom by 8 here. And we'll have 11 on the top, and we will have 2 on the bottom, which is also what we were asked to prove, QED. Okay, let me just check. Yes, here we are. The tan 3 theta was equal to 11 over 2. Okay, so we've finished. But what I'll do just for a moment is show you a different way of doing the first part.